Here we have a chart, a table of numbers, in which we need to go ahead and figure out an equation for the time of the day compared to the altitude in degrees of the sun when we're way up north during the summer where the sun never sets. So if you've not done so, go ahead and plot these points. When you plot these points, you get a curve that looks about like this. You should realize that this looks pretty close to a sine curve or a cosine curve. It's just shifted to the right and shifted up. And that's really what we need to go ahead and find, is the equation that models this data. Remember, your A and your B are always max minus min divided by 2. Well, here it looks to be about your maximum, here it looks to be about your minimum. But let's go ahead and find your max and min looking at your table. Here you'll see your minimum, here you'll see your maximum. So let's go 40.5 minus our minimum of 6.5 divided by 2, and we type that into our calculator and we get 17. Remember, your D is max plus min divided by 2. So we're going to take our 40.5 and add our 6.5 divided by 2, and we get this here. Now, remember, your period is how far you have to go horizontally before it starts to repeat. In the context of this problem, since we're watching the sun go, how far it goes up in the sky and coming back down, we know it's going to repeat every day. In other words, our period then, since our time is given to us in hours, our period will be 24. Remember, your value for B is always your 360 or your 2 pi, whichever one you choose to use. In this case, it doesn't make a difference. 360 degrees divided by your period. So we go ahead and divide those and we get our B value. So in writing your cosine function, you know your A value is 17. Your B value we just figured out is 15. Your D value is a positive 23.5. So now we need to figure out your C value. Remember, C is how far you have to move it horizontally before you get to your maximum. Your maximum on a cosine is normally right here, right on your y-axis. We need to move it from here all the way over to here to get to your maximum. How far over is that? You'll realize you can also just find that in your data. Looking in your data, when did your maximum occur? We know our maximum is this here, but the when, that's what we're talking about at 1 o'clock here. But notice that this is 1 in the afternoon. How many hours after midnight is that? Well, that's 13 hours after midnight, so that means our C is 13. So we're moving our graph from our axes over to the right to match this up. So whenever you move to the right, you end up having to subtract your C value. And here's your equation.